So, okay. Well, I mean, just want me to go through. Do you have a specific question, or you just want me to start at 1 and go through 16? And
yeah, start. Yeah, from the start to end.
all right. Let me take a picture of this and make it big, and then I'll share my screen with you. Actually, while I'm here, let me steal about 2 or 3 of these things. Do one more. All right, screen share coming your way. Okay. Well, let's see. So here's number 1. Whenever they talk about a uniform density, you're automatically supposed to associate that with a rectangle. We have a normal bell curve, a normal distribution, which looks like a bell curve, but a uniform distribution is shaped like a rectangle, which is kind of nice because then all we have to do is find the area of the rectangle and call it a day at that point. So let me kind of pull up a little formula screen so I can type stuff in. Okay, so in this question it says the graph at the right, uniform density for a friend who's late. Find the probability that the friend is at least 13 minutes late. So if you think about it, at least 13 means, do I want less than 13 or more than 13?
Or at least, or more.
Right. So like if they show up at 13, that's okay, but at 14, 15, 16, so I'm looking at 13 and above. So when I'm looking at this rectangle, I'm going to start where 13 is, and I'm going to go up, and I just want to find the area of that specific rectangle. Well, if I go 30 minus 13, which gives me the length of the bottom side, I get 17. And the height of the rectangle is 1 over 30. So I just want to multiply those two numbers together. So I want 17 times 1 over 30, which is where they're getting the 17 over 30 from. Does that work?
Okay.
Okay.
It was okay.
Yeah, and there's only, I mean, uniform density is just one specific topic, so you're only going to have to do this once. All right, let me see what that is. Oh, somebody figured it out. Okay. Someone is playing Clash of Clans. How silly. Okay. All right, let me go back to that. I got rid of them. All right. Wasn't the intention, but there we go. Okay, so your number 2 says determine the area under the standard normal curve. Find the area under the normal curve, give to the left of -1, plus the area to the normal curve to the right of 1. So another way of saying is I don't want the area in between. So let me pull up my calculator here. Oh, come on. Okay, so in this case, I'm going to go to norm CDF, and I can do this one because it wants to the left of -1 and the right of 1. So I can either find the area to the left and then add it to the right of 1, or I could just find the area in between and then subtract from 1. So it's kind of like whatever's easiest. And so I'd rather just do it once and subtract. So that's what I'm going to do is I'm going to set the lower bound to -1, the upper bound to +1, and since it's a standard normal curve, so they're talking z-scores here, that means the mean is 0 and the standard deviation is 1. And then I'll calculate that. Now that's not my answer, but if I subtract that from 1, that's my answer. So that's where they're getting the 0.3173 from. So again, I could have done a CDF on the lower side and a CDF on the upper side, but just easier to do it that way. Second question, find the area to the left of -1.53 plus the area to the right. So kind of the same idea. I can either do it twice, going once before -1.53 and then once above it, or I could just do between and then subtract. Oh, yeah. Okay, so that's what I'm going to do. Go that route. So norm CDF, put my lower at -1.53 and my upper at 2.53. And since it's z-scores, then your mean is 0, standard deviation is 1. And again, that's not my answer, but if I subtract that from 1, that would be my answer. So that's where we're getting the 0.0687. Part C, the area to the left of that number plus the right. Okay, just rinse and repeat at this point. All right, so I'm going to find in between those two values and then subtract that result from 1. So I'll go to distribution, norm CDF, -0.23 and 1.4. And then jump in there. Okay. And again, that's not my answer, but if I subtract that from 1, there we go. Any questions so far on that?
How do you know when to subtract from 1?
Well, the way they worded the question, they want to the left of this number and the right of this number. Let me see if I can pull up a nice bell curve normal model. See if I can just get an image that I can show you kind of what's going on here. Yeah, images for normal. Yeah, I'll just steal this. Oh goodness, that's not what I told you to do. Okay, so when they told me to the left of -2.3, so I'm on this bell curve and I want everything this side of that number. And then the other number, I want everything to the right of that number. So I can either do norm CDF twice, so I can figure out this probability and then add it to that probability, or just find the two numbers in between. So if I find the in-between area, that's where I want to subtract 1, because I didn't want to know the probability between the two values. I wanted to know the outsides of the tails in that question. Does that make sense?
Yeah.
Okay. I don't know if me pointing with the mouse is making any difference here. All right, so I'm going to go to your third question, and then I'm going to jump back and see who showed up at this point and see if I can kind of spread the love around, so I don't just focus on one student. Okay, so third question says, the lengths of a particular animal's pregnancies are normally distributed with a mean of 270, standard deviation of 20. What proportion of pregnancies last more than 295 days? Okay, that's a norm CDF again. This time it's not z-scores. They actually give me a different parameters to type in. So read this question. They want more than 295, so I'm going to go 295 on the lower end, and on the upper end, my upper bound is going to be infinity. So the way this calculator reads infinity, it's 1e99, and then I'll put in the mean and standard deviation of what they told me to, so 270 and 20, and then I'll hit enter, and there you go. So 0.1056, which is what they got. Part B says between the 2 days, so I'm going to go back to that norm CDF and then change the lower bound to 235 and the upper bound to 280. Everything else I keep the same, and that's where I get the 0.614. Let's see, no more than 245. Okay, so that one we got to think about. When they say last no more than 245, what's like, is 245 the most I could have, or is that the least that I could have?
That's the most you can have.
Right, no more than 2. Okay, so no more than 245 means that's my upper bound is 245, and then my lower bound is negative infinity, so that's negative 1 e to the 99. And that's where they got that number. Now it's just coincidental that it's the same as that first one. So it's not, I suspect it's probably equidistant from the mean, which is why we're seeing the same two numbers, but oops, okay. D says a preterm baby whose gestation period is less than 220 are preterm babies unusual. Okay. In statistics, it sounds sometimes that they're asking for your opinion and they want to get your thoughts. They don't. They don't want your opinion. They want some fact. So we're in the middle of norm CDF. First thing I want to do is calculate that probability of getting smaller than 220. So norm CDF, I have a lower bound. Upper bound is up to 220. And that's where we're getting the 0.006. And so is this, so in other words, the likelihood of getting a preterm baby is less than 0.6% of the time. And what they're saying is that we're measuring this in terms of 5%, so 0.05. So if it's less than 0.05, then that's significant. If it's bigger than 0.05, then that's an average, normal, boring event. No one cares. But less than 0.05, we call that statistically significant and unusual. So because our probability was 0.0062, then we would definitely consider that to be unusual, and the justification is because it's less than 0.05. We are our last unit's on hypothesis testing, and so this is a big deal with hypothesis tests coming up. Now for this test, it's just knowing how to use norm CDF, and it seems like we're just in love with that particular screen. But anyways, any questions on this number 3 here?
No.
Okay. I'm going to jump back to see who's there, and then I'll kind of open it up. So what I'm doing is kind of open it up there. I'm just going through someone's test. I've gone through the first 3 questions. I pretty much plan on going to 4 and then 5 and then 6. So let me kind of open it up. Do you guys have any other questions you want me to specifically focus in on? Or is it okay if I just go through the entire practice test 1 through just in order? I know what Jessica's thoughts are.
I was about to say in order.
Jessica wants no creativity. So Yenny, Deidre, and AJ, do you guys have any specific in order? Okay, Deidre's going to pop some popcorn and enjoy the show. Okay.
I prefer order also.
All right, and someone brought a kid. Awesome. Mine are asleep. All right. Just to forewarn anybody, so when I share my screen, if you got your mic turned on, then as soon as you make a sound or sneeze or cough, then it automatically goes to your screen. So if you want to avoid that awkward checking at you and your jammy approach, then I suggest just turn the mic off, and I'll kind of stop per question and see if I need to go back through something. So just wait for me to say, hey, does anyone have any questions, and then I'll kind of zip through that. But right now, I need to pull over a couple of questions. So, you guys can't see this, but I am copying questions over so that I can talk about them. And I'll kind of do this. I think sets of 3 sound pretty good to me. Alright, label this as 4. And then 5. Okay, so bear with me just a second here. Alright, I am just about ready. Alright, so share screen's coming your way. Or screen, whatever, screen share's coming your way. Alright, so everybody should be able to see 4. Now I pulled this off of somebody else's practice test, so you're going to see some wrong answers and some right answers. I've done none of this, so don't think I'm a doofus and getting everything wrong. Okay, so the question says on number 4, find the z-scores that separate the middle 13% of the distribution from the area and the tails of the standard normal distribution. Okay, now, question here is when we've got norm CDF and we have inverse norm. Norm CDF says, give me the numbers that are the upper bound and the lower bound, and I will give you a % back. Inverse norm says, give me the %, and I'll give you the lower bound. Okay? So what I have to translate for just a second in this question, if I want the middle 13%, let me kind of scroll back up here. So I'm looking at this normal curve, and I'm looking at the middle 13% of the data. Okay, well I want to know where this border is, and inverse norm is really picky in that it only measures things in terms of less than. So what I need to do is I need to translate that 13% to what % of the data is less than that amount. Okay, so I'm going to start by figuring out what's, well, the middle 13, how much is on the tails. So I'm going to take 1 minus the 0.13, and that's 0.87. So it's 87% of the data that's on the left side on the right side. And it's a symmetrical curve, so it's even split. So then I want to divide that number by 2. And so there's 43.5% on the left and 43.5% on the right. Okay? So I'm going to use inverse norm, and I'm going to tell inverse norm I want you to find the z-score that relates to 0.435. So I'm going to go to distributions. I'm going to go to inverse norm, and it's going to say what's the area, and I'm going to go 0.435, And since we're talking z-scores here, it's a standard normal curve. So mean of 0, standard deviation of 1, then I'm going to hit paste. And it's going to spit out my lower end z-score. So that's negative 0.16. And since this is symmetrical, that means the bottom number is negative 0.16, which means the upper number has to be 0.16 as well. So kind of go back up to my picture here. So now that I know that this side is negative 0.16, then I know that this side has to be 0.16 also. So let me kind of stop and say, does anyone have any questions about that, or are we all good? You can turn your mics on.
I think we're good.
All right. Number 5 says, suppose the data represents the number of chips in 25 different 2-ounce bags of chocolate chips. Use the normal probability plot to determine if the data could come from a normal distribution. Okay, so this is just a property question, just understanding what normal means. And honestly, this particular question is understanding this little chart here. And so let me kind of, I'm going to take a picture of this and I'm going to make it really big. I want to make sure we understand what we're looking for in this chart. Okay, so what they did is they took all of this data and they put it in order in a calculator. Now we don't see this, but this is what this chart means. So they put all this in order and they said, okay, if it's normal data, we're going to pair up the smallest z-score with the smallest observation, and we're going to partner the biggest z-score with the biggest observation. And they sort of went through and partnered all of these things up with z-scores in order. And so what we're looking for to determine if it's a good normal fit, does it look like a does it look kind of like a line? So they gave us sort of this straight line in the middle here, and yeah, it's not too bad. It's, you know, it looks like there's a little curve going around it, but they did give us a little border here. And so what I'm trying to notice is either it's going to look fairly linear, which is a characteristic that the data is normal, or it's going to look just all over the place and it's going to be outside of these blue curved lines, in which case a normal model would not be appropriate. Okay? So the correct answer choice is that the relation is approximately linear. So the sample data could have come from a population that's normally distributed. Okay, it's called a normal probability graph. The normal probability graph is not crazy looking. It looks fairly linear, so I can say that the relationship in the data happens to be fairly normal, if that makes sense. B right here, the relationship is not, okay, so that's nonsense. Oh, sorry, is not linear, so it could not have come. Okay, that, if the data is not linear, then okay, so B could be a good choice depending upon if the data is crazy or not. And then I think C and D, they kind of mix the two statements up, so C and D would never be picked. But it's either going to be A or B, depending upon the type of graph that you get. Okay? Any question about that one, or are we good?
I'm okay.
Okay. I don't know who's driving this boat, but all right, we're good. All right, then last one before I go and grab some more questions. It says determine the mean and standard deviation from the given population and sample size. Okay, so if they tell us that the population has a mean of 82, and I reach in and I grab 81 random people and I add them up and divide by 81, then the sample mean should be 82. But the standard deviation changes. So the standard deviation is going to be so it's going to be this, sorry, try this again. The standard deviation of the sample is going to be the population standard deviation divided by the square root of the sample, which is where they're getting that 3 from. So I'm going to pull out a calculator here. So 27 divided by the square root of 81 happens to be 9, so yeah, I just typed that in. Yeah, I did that. Okay. Anyway, so we get 3, and that's what they're asking about on that one. So, word of caution, we've got proportional data and mean data. So there are 2 different formulas you have to pay attention to. So if it's mean data, then that's just standard deviation divided by square root of n. And if it's proportional, then it's the other formula where it's PQ over n, square root of PQ over n. So just be aware of that changing on us. And I am going to stop sharing my screen for just a second. And I'm going to grab 3 more questions. So take a brief pause, I guess. Oh, this one's long. All right, hold on. All right, so what was this? It was 7. Okay, almost. Alright, so I got 7, I go to 8, and again you can see absolutely none of this. Alright, one more. Let me grab 9 and then I'll share my screen again. Alright. Coming right back at you. There we go. Alright, number 7. That's weird. Okay, so it says the reading speed of a second grade student in a large city is approximately normal, with mean of 88 and a standard deviation of 10. What's the probability that a randomly selected student will read more than 94 words per minute? Okay, this is Norm CDF again. So let me go there. Is it sample or is it just, let me reread this. Nope, looks pretty straightforward. Okay, Norm CDF. They want more than 94, so my lower bound is going to be 94.
I can't see anything.
Oh, you can't see anything?
No.
Let me look. Oh, I see one concern. We're going to try this. This should work better. I forcibly muted someone. Can you see now?
Yes.
Okay. Yeah, that's that. Yeah, it's just like I said. If there's any sound that picks up, that automatically steals the screen, and which is fine. I don't know if you guys are thrilled about watching me do all this math. All right, lower. Where was I? Okay, so it says read more than 94. So my lower is 94. My upper is going to be infinity, so that's 1 e to the 99. And they give me a mean, and they give me a standard deviation of 10. Alright, so that's where they get that number from. Part B says, what's the probability that a random sample of 10, okay, so now I'm starting to look at sample means and sample standard deviations, that a random sample of 10 second graders will result in a mean of more than 94. Okay, so kind of looks like it's almost the same setup, but I'm going to adjust the standard deviation there. So, sorry, let me go to norm CDF again. And all I'm going to do is scroll down, because they're still saying, in part B, they're still saying 94 or more. But I need to adjust that standard deviation. So divided by the square root, and they said a sample size 10. So I just need to change that to say that divided by the square root of 10. And then I'll hit enter, and that's where they get that magic number. And then in part C, they're changing the sample size to 20. So I'll go back to norm CDF and just change where I put the 10 to say 20. Everything else stays the same. And that's where they're getting that number. That's the first three parts. Then we get to part D. What effect does increasing the sample size have on the probability? Well, notice as we got a larger and larger sample, our probability got smaller and smaller. So that's what we're picking is, let's see, the probability, increasing the sample size decreases the probability because standard deviation decreases as n increases. So that's why. So you're looking for some sentence like that. That if I increase sample size, then the the probability using samples should get smaller, something like that. And then the last part of that question, teacher instituted a new reading program. About 10 weeks into the program, it was found the mean reading speed of a sample of 18 second graders was 90.9. What might you conclude based on this result? Select the correct choice. Okay. So I need to calculate a probability on this. Let's see. So I want to know what the likelihood of 90.9 or something bigger than it, given this information about 18. Okay, so let me go back to norm CDF. All right, and this time I'm saying 90.9 is the lower end, so I'm looking at anything that and up. And let's see, the mean of the population stayed the same, but this time I have 18 in my sample. And so I'll calculate that. Okay, so I get 0.0193, so about 10%. Okay, so I guess the question, and I'm going to answer it myself, but what's the magic statistically significant number? And that's 5%. So the fact that after doing this program for 10 weeks, you got an improvement that would only show up randomly 10% of the time, well, that's not enough to get excited about. We're defining on purpose that the get excited about number is 5% or lower, and we didn't get that, so program basically is a bust and isn't really working. You know, so aside from spending time with kids, I guess. Any question on that particular concept? Anything I talked about? Silence is golden. All right. Can I come over here and all right. We'll keep going. Number 8, the shape of the distribution of the time required to get an oil change at a 15-minute oil change facility is unknown. However, records indicate that the mean time is 16.6 and the standard deviation is 4.1. To compute the probabilities regarding the sample mean using the normal model, what sample size would be required? Just straightforward, the magic number for sample size is 30. So if we want to make sure that our sampling distribution is a normal model, in other words, that we can use norm CDF and all of that, then I need to make sure I at least have 30 in the mix. And then the probability, let's see, probability of the random sample with size 35 is less than 15. Okay, so that's norm CDF. I keep doing that. Oh, distribution stuff. Okay, sorry. It's going to be a long night for me. Less than 15. Okay, so less than 15 says the lower bound is negative infinity. And the upper bound is 15. The mean is the population information. So historically, the mean is about 16.6, so that's the mean I'm going to go with. And then the standard deviation would be 4.1 divided by the square root of 35. And there we go. Okay. So less than 1%. That's awesome, guys. All right, any question on that one? All right.
Nope.
Oh, yes?
No, go ahead.
Okay. I'm just assuming if I don't hear anything, then y'all are doing great. Number 9, describe the sampling distribution of p hat. Assume the sample size is 25,000. Our sample has 1,100 people in it, and the probability of success is 0.182. Okay. So, in other words, in the population, the probability that, whatever it is we're talking about, the probability that it being successful is going to be 0.182. So that should match the sampling distribution, which is down here. Now the standard deviation is going to change. I guess let me come back up here real quick. Describe the shape. The shape is going to be approximately normal because our sample size is less than 5% of the sample. And if we've got this sample size condition of NP times 1 minus P, I just call that Q, being greater than or equal to 10. So anyway, so it satisfies those conditions, so that's the choice we're looking. The question is, how do I get standard deviation of P hat? Okay, so that would be the square root. Come on, you. What are you doing? Uh-oh. Alright, bear with. Something's freaking out here. Why are you freaking out on me? Alright, square root. Oh, this is not cool. Alright, well. Oh, that's terrible. Why do I have... Oh, I hope this is not a bad sign. Let me check and make sure you guys are still with. Okay, we're all still with. My computer's freaking out because I've got too many things going on at once. Oh, let me try closing down a couple things. Okay. Oh, no, that didn't fix anything. Alright, well, let me just go to the calculator then. The formula is the square root of our original, P, so 0.182. Times the 1 minus 0.182. And then we're going to divide that by the sample size, which is 1,100. So that's a little different for proportions than it is for means. But you do get the formula chart on that. So anyways. And that is that. All right. I don't think... Okay, so I need to go still 3 more questions. So I'm going to stop sharing for a moment. I'm going to figure out why this thing is freaking out on me. Let me open up. Okay, so I'm going to copy 3 more questions, and I'll jump right back into it. All right, bear with. I've got this crazy error that just showed up all of a sudden. why it's doing that. Okay. And that's just going to be annoying, and it's just going to sit there the whole time. All right, so number 10. All right, number 11. And number 12. All right, let me go share my screen. And I've got this little strange glitch that's showing up, but I seem to be able to work just fine around it. It's just annoying. This little formula thing just won't go away. And I can't figure it out until I close down recording, so it's just going to have to sit there. Sorry. All right, number 10. According to a study conducted by someone important, the proportion, okay, so we're dealing with proportional data, or satisfied with the way things are going, is 0.76. Suppose a random sample of 105 is obtained. Describe the sampling distribution. Okay, the sampling distribution should have a mean of the proportion, so the mean of the p-hats should be the same as the population, which is 0.76. The standard deviation is that formula with the square root. So the square root of 0.76 times 1 minus 0.76 and divided by sample size, which is 105. Okay, so that's where they're getting that 0.041 blah blah blah. That's where they're getting that number from, using that formula. Okay, part B says, using the distribution from part A, what's the probability that at least 82 are satisfied with their lives? Okay, so the temptation we got to watch out for here is we're dealing with proportional data, so anything I type in the calculator for this problem needs to be in terms of a proportion. So when they say at least 82, I'm not using 82, not the way it is. I need the proportion that matches with that. So that's 82 divided by 105, which is the point. That's so 0.78. Okay, so in my head I need to think. Okay, so when they say at least 82, they mean at least 0.78, and then I can use the other information from the problem. Okay, so at least is the smallest, that's the lower bound, and then I want an upper bound. Okay, so I'm going to go to my distribution menu. We're dealing with norm CDF. At least, okay, so 82 divided by 105. Upper bound is positive infinity. The mean is the 0.76, and the standard deviation is that formula I typed in, so I got to retype that in here. If you type in the decimal, it'll still work, but your answer will be a little bit off. Now, I will give you credit for it, but I'll have to go in and adjust that rather than the calculator or the computer automatically giving you credit. Make sure I don't forget that number, 105. I think I got that in there right. Okay, and ta-da! Okay, so the probability that it's at least 82 is 0.3076, which is what I got the calculator to say. Let's see, then part C says fewer, see 77 or fewer, so that means 77 is an upper bound. But again, I'm not typing in just 77. This whole problem is proportional, so I need to translate that into proportional. So norm CDF. Let's see, so the upper bound this time is 77, so my lower bound is infinity. And okay, not just 77, but 77 divided by 105. Everything else is the same though, so I can just go down and hit enter. Yay! All right, so that's how I get that question. Any concerns with how to do number 10? Are we good with that? All right, silence is golden apparently. Actually, could someone just double check that you guys can still hear me? If I've been talking to myself for 5 minutes.
Yes, we can hear you.
Okay.
I hear you.
Thank you, all of you at once. That's fabulous. I get really nervous when I start talking to myself. I mean, just never mind. Okay, number 11. Katrina wants to estimate the proportion of adults who read at least 10 books last year. Okay, automatically, she wants to estimate a proportion, and they already throw at me this number 10, so I'm not using 10 the way I see it. I need to make sure that it's some sort of proportion when I'm setting this up. Of course, I haven't even read the question, so I probably should keep reading. To do so, she obtains a sample of 100 adults and constructs a 95% confidence interval. Matthew also wants to estimate a proportion who read at least 10. He obtains a random sample of 400, so he's got a larger sample and constructs a 99% confidence interval. Assuming both Katrina and Matthew obtain the same point estimate, what estimate will have a smaller margin of error justify your answer? Okay, so the sort of theoretical conversation that you're having here is what matters more, sample size or confidence level? And since the answer is clearly there, if you're going to go 400 versus 100, the fact that you have more than 4 times the sample is already going to compensate for the stricter confidence level. So, in other words, sample size always trumps changing anything else. If I want a more accurate estimate, I just need a larger sample. And okay, so there you go. It's just a theory question. And then number 12, and then I got 4 more to go. We're almost done. Construct a confidence interval, population proportion of the following level. So I got 180, successes, sample size 300, 90% confidence. Okay, so I believe we go to test, and this is it's a proportion, so it's a 1 prop z interval right there, and it's going to ask for basically the 3 numbers that it just gave us. So 180, 300, and 0.9, and then I just hit enter, and it gives me all those numbers. Yay! That's a nice, pretty straightforward one. Okay. All right, I'm gonna go grab the last 4 questions and then kind of open it up to any random thoughts you guys want to ask me. But let me stop sharing the screen. Let me go get the 4 questions. Let's see, probably about confidence stuff. So. All right, so bear with. All right, so I got 13. Let me grab 14. All right, let me get 15. And last but not least, number 16. Oh, I get to refer to the formula chart. I haven't done too much formula chart stuff here. So, all right. Okay, so screen share coming at you. All right, 13. In a poll, 104 of 1,040. So already, this is starting to sound like a proportion. Randomly selected adults age 18 or older stated they believe there's too little spending on national defense. Use this information to complete the following. Obtain a point estimate. All right, point estimate means if 104 say there's an issue, what percent of the time is that? So literally just 104 divided by 1,040. And so we get a p-hat of 0.1. Part B, verify the requirements for constructing a confidence interval are satisfied. Let's see, got a large enough sample. Let's see, what else we got? Yeah, sample size, NPQ is greater than or equal to 10. So, yeah, so it's definitely large enough. Part C, construct a 95% confidence level. Okay, well, since we're still in proportion land, I want a 1 prop Z on this. 1 prop Z interval, sorry. We don't know about tests yet. That's the next unit. So 1 prop Z interval, and it's 104 out of 1,040. 40. And 95, so 0.95. So those are your two numbers. Okay, Part D says, is it possible that more than 15% agree? And, okay, so with the confidence level, this means I went out and I talked to 1,000 people. Well, what if I go do that again? What if I go out and I talk to 1,000 people? Would I expect to see some different numbers? Yeah, I would. But the question is, I wouldn't see too big a difference in my confidence level. It would still hover around the two numbers that I'm seeing. I might go down to 7, it might go up to 13, but pretty much between 8 and 11% is really what people are thinking. It's not. I mean, 10% is my sample, but what's the population thinking? And since 15 is outside of that interval, then it's possible, but it's not a very likely scenario. I mean, it's always possible for some randomness to happen, but so that's why you want choice A, is that it is possible, but because it's outside of our interval, it's not. There's a very low likelihood that could happen. And then part, let's see, Part E says use the results of Part C to construct a 95% confidence interval.
You're breaking up really bad.
Breaking up bad? If it makes you feel better, my wife just walked in, so that might have I don't know. Let me know if you still can't hear me. Can you hear me now? Still breaking up bad? Let me try this. I don't know if me resetting it does anything. Alright. Alright, if something happens again, let me know. Alright, so it says use this other interval to construct who do not believe there is too little. Okay, so if this group right here, the 0.1, believe that there is too little, then the not believe would be the other side of the coin. So the other, what is that? 1040 minus 104. So let me figure that out. 1040 minus 104. So 936. So if I go right back to where I was, as far as the one prop z interval. Alright, and do the 936, and I think it's still 95%. We'll double check this. Yeah. Anyway, so that's all they're saying, is they put this word not in there, and so you're supposed to go back and change it from the 104 to the other people that said no, whereas the 104 said yes. All right. Everything good audio-wise? We can hear me just fine? Anyone?
I can hear you.
All right, perfect. I just need one person. All right. Number 14. Determine the point estimate of the population mean and the margin of error for the confidence level if the lower bound is 19 and the upper bound is 31. So let me kind of scroll back up here. So let's pretend, instead of giving you all of this information about the p-hat and the standard deviation, what if I just give you the confidence level? Can you tell me p-hat? Well, all I'm asking you to do is tell me what's halfway between 19 and 31. So I'm just going to average them. So 19 plus 31, and then divide that by 2. Okay, so the point estimate is the middle of those two bounds, so it's got to be 25. And then the margin of error refers to how far up and how far down do you go to get from the point estimate to the upper and lower bound. So I just take the 25 and minus out the 19, and that gives me my margin of error. So if I go up from 6 up from 25, I get 31. If I go 6 down, I get 19. So that's all that was asking. Oh, I can hear someone. Maybe not. Oh, I might have to go. Who am I tattling on? Oh, okay. I won't tattle. Oh, no, we got it. Okay, cool. All right. All right, almost done, almost done. All right, 15. What is this? You are given a bunch of data, and you're given a graph about box plot, normal probability plot. Okay, but the point being, you're given some raw information, and your first task is to find a confidence level. So it hasn't happened too much on this test yet, but we're just going to go type in these numbers. So I'm just going to real quick type them in. Hopefully I don't screw this up. 51, 41, and 43. Okay, so got all those in. Hopefully I didn't make a mistake. It wants me to do a confidence interval. This is mean data rather than proportional data. So I'm going to go over to my, let's see. So we have to have a brief conversation about this. So it's either a z-interval or a t-interval. So to make that decision, I need to go back in what they told me and for the population standard deviation. So if they don't give me population standard deviation, it is a t-interval. And I don't see anywhere in here where they're saying population standard deviation. So we're going to go with that. And since I typed in the raw data, then I'm just going to tell the calculator, hey, go with the data route. And it's going to ask me, well, where'd you put the data? I put it in list 1. Do you have a frequency list? No, we usually won't mess with that unless, like the first unit on histograms, we talk about frequencies. And then confidence level, they want a 90%. And then let it do some thinking, and there's my numbers. Yay! Alright, and then the next part asks about what does this actually mean? What does the confidence level mean? And it should be something along the lines we are 90% confident that the true population mean is somewhere between 41 and 48. Okay? Which is, in this case, that's what that first choice is saying, that we are 90% confident that the interval actually does contain the true value. So you want to be careful about thinking that 90% means chance or probability. That's not what it means. It's a measure of confidence, not a measure of luck, I guess. And then the last part, the normal probability plot and box plot. Okay, so I didn't take the picture, or I didn't copy the picture over. But if you click on this little icon, it's going to bring up a box plot of the data and the normal probability plot. And we just have to verify that it behaves normal. There's no outliers in the box plot, or sort of has a nice normal shape to it, the way we'd expect. Anyway, so I'm not going to show that just because I didn't think to do that. All right, and then lastly, it's number 16. Doctor wants to estimate the mean. How many subjects are needed to estimate the mean within 2 points? Within 2 points of a 99% confidence level, assuming the sample standard deviation is this. Then we'll switch that to a 90%, and then just kind of talk about how that changes. So I have not. Part of it I did from memory, but I have not talked about the formula chart here. And then this is something I'm just going to go straight to the formula chart. So let me track down, because you should be getting this when you take your test. And I'm looking for the chapter we're in. Sampling. Where are you? To estimate a sample size. Is that the right one? Oh, okay. That's the one we want. Is this one right here? Okay. So let me take a picture of this. Well, okay. So this top one. I didn't mean to take a picture of that. This top part of the chart refers to proportions. You can see the p-hats there. Down here to estimate a population mean with margin of error, blah, blah, blah. So I actually want this bottom chart, or that bottom formula. Alright, so sample size would be the z-score times the standard deviation divided by the margin of error. Okay, so in this, we have the standard deviation of the sample is 15.5. I need to go find the z-score that correlates to half of my alpha. So can I go back up here? Where is it? So in a 99% confidence, okay, let me go. I'm coming back to this one. I'm not going away, but let me kind of go back. Well, no, I got rid of that picture. Okay, never mind. Oh, no, I still have it. Okay. So think about a 99% confidence means I'm looking at the middle 99%. So if I'm looking at the middle 99%, that means I got 1% for the tails. So each tail should have 0.5% of the data. Where I was going with this. Okay, so I need to get the z-score that correlates to that. So I'm going to do inverse norm. And the inverse norm, keep in mind it's all in terms measured of less than. So that's 0.995, because 0.995 is below that upper tail and 0.005 is above it. And then a mean of 0, standard deviation of 1. And then I hit that, so I get a z-score of 2.57. Okay, so now I'm here, and it says to take that number, times it by the standard error, so the standard deviation, so 15.5. And then to divide that by the margin of error, and so I want to be within 2 points, so I believe this is what they did. And then I want to square that. That's what that formula says. Take that number and square it. So then, ta-da! I get 398.5, and we always round up. So if I talk to 399 people, then statistically I should be that level of confidence. Then to do the 90% confidence, so I'm going to repeat this process. So 99% confident, I'm going to go back to my picture here. So I'm looking at the middle 90%, which means I've got 10% left for the tails. So I got 10% between the two tails. And so that means 5%'s lower, 5%'s upper. Okay. So because I want to know everything below that upper one, I'm going to do inverse norm. And I want 0.95, because the extra 5 comes from the fact that I've got that lower tail I'm taking into account. Mean of 0, standard deviation of 1. Hit enter. Okay, so that's my z-score is 1.64. Then I want to multiply that by the standard deviation of the sample. And then I want to divide that by the margin of error, which was the 2. And then I just want to square it. And so I round that number up, the 162.5, I round that up to 163. Alright, and then the very last question talks about what happens when you decrease the confidence level. So decreasing the confidence level decreased the sample size that was needed. Okay. Alright, so at this point, I'm going to stop sharing. I got a sense I might have to go back. Let me kind of roll over here. Any questions, anything? I mean, I'm going to send out this recording so you guys can go back and watch this to your leisure. But any questions I can field real quick?
How many questions did you take?
16. I'm very lazy. Anything else? Is the final comprehensive? Yep, I'm going to steal from all the exams, but in all fairness, there is there's another practice final. So, and you get a formula chart, and I think I should double check this before I say something bold. I think I put that you can bring a page of notes with you to the final.
Yay!
Oh, that we heard. Okay. Oh no, that one. Deidre doesn't get to know that. Deidre will have no idea what's going on. I'll double check that, but I think that's what when I do a face-to-face class, that's what I do with them, is I let them bring a page of notes in. So, on top of the normal formula chart that you get for the test. So, anything else I can help with?
Which test is the hardest one?
Honestly, okay, so the test 2 is usually the roughest. It's the one that's got the probability on it. This test, honestly, if you don't know norm CDF, you're in trouble. And I mean, it just feels like I'm doing the same calculator screen. And so I'd say test 2 is the hardest. Test 4 is going to be the second hardest. But it's not because of the statistics part. It's you have to decide if you have mean data or proportional data, or if you have 1 sample or 2 sample. So there's a lot of decisions to be made, and once you make a decision, your calculator is going to spit out a number. But if you make the wrong decision, then you're basically screwed at that point. But anyway, so there's less questions on the 4th test, and so typically I see interesting scores on it. But if you're here, you've survived the hardest one.
Okay, good to know.
Good to know. Anything else I can help with before we all turn into pumpkins? Nope. All right. I'm going to, Deidre, in case you didn't catch that, I said that for the final, I'm going to let you guys use a page of notes on it. I'll make an announcement as we get closer. I mean, in theory, I said you guys could work ahead and take tests early, but I'm not getting too much business on that. Everyone's kind of waiting until I say it's test week. Now I should care. But anyways, all right. So I'm going to stop this, and then I will. I'll send the recording out